Okay, we'll go ahead and get started, and I'll just go ahead and hit pause here in just a moment. But and I think this is accurate in the movie. They're actually testing how hard, Vladimir Gargarian or something like that. It's where Rocky, Sylvester Stallone, okay, in the fourth installment, boxes for the world championship a Russian named Vladimir. I want to say it's Gargarian. I'm not quite sure what it is. But anyway, in this movie, he strikes this machine, and I distinctly remember that it reads out somewhere around 2,000 newtons upon doing that. Okay? Does anyone follow the Rocky franchise? Does anyone know anything about it? Have you seen? You're maybe some of the more recent movies, right? You've watched all of them, okay? And not that you would be looking for this, but according to this, Rocky is more so old school, right? Because he does the exercises very similar to what his counterpart does, but it's with weightlifting and moving rocks and moving wagons and things like that, rather than having the high-tech machinery that would track this. But anyway, he strikes this with around 2,000 newtons. Okay, so while testing, he could accelerate his punch and strike the machine moving at 7.18 meters per second. I don't know, maybe it was. We're just making a problem out of it. It was 0.31 seconds earlier, his fist was moving at 0.71 meters per second. What was the momentum of his punch? So I'm just going to go ahead and pause here for just a moment so you can go back and if we're going a little too fast. I just announced to the class, do we feel we approach these very similar, the same way every time? And the response was yes. So we're probably up to about number 18 by now. You've read the problem. What is the next thing we should do?
Figure out what you got.
Okay? And again, some students might say, well, this doesn't work for me. Maybe. But there again, we've got 18 students in here. We can't do this 12 different ways for 18 students. We just do the best we can with what we have in front of us. Okay, so what do we know in this problem?
The force is 2,000 newtons.
Okay, so the force, 2,000 newtons. What else do we know?
Initial velocity is 0.71 meters per second.
It is. What else do we know? The final velocity. Okay. Do we know anything else? Okay. And then it's about this time, I think there's 4 numbers up there. 1, 2, 3, 4. Here they are. What is the question asking?
Momentum.
What is the momentum? Okay. So do we even have anything in here that we can solve for momentum? Because there's 3 variables, correct? So you have to know 2 of them.
Mass.
We need to know the mass to calculate momentum. What else?
And we already have final velocity.
And you already have your final velocity. Okay? So with this, you had correctly said we need to find the mass. Okay? Well, that might be true. Where do you find mass besides that of the momentum formula? Where else do you find? In your force formula, mass is also there. But we've got the force, but we don't have the mass. But if we need to find this, and we don't have a momentum, but we have the final velocity, with this given information, is there something we can do to get us one step closer to solving for the mass? We can solve for acceleration. Okay, so that we don't know. And then finally, look, we just made a map. We're looking for that. Mass, acceleration, and product. It's a map. And the destination is knowledge. So let's see if we can get there. I need my applause sign, Mrs. Herbert. Maybe the bulbs are burnt out. Okay. So, did you know that a lot of shows actually had laugh tracks, I think, going back and I don't know, if you don't find something funny, why would you laugh, right? Maybe that's true in here too. All right. So, what can we do in this information, or with this information? You said we can find the acceleration. So, how would we go about doing that? If we're going to, obviously, we don't know it if we're going to find it. So, what is on the right-hand side of that equation? Okay. So there again, we don't need to look up here. It's all written over here. So VF comes first. That is 7.18. What are we subtracting from that? 0.71. And what goes on the bottom of our fraction? 0.31. Now, we probably know this up to this time, what it is that we need to do, but if we really want to be accurate, do we want to divide first or subtract first?
Subtract.
So then we would do this. Are we going to cross multiply at all? No. Okay, so let's do our subtraction first. And
6.47 meters per second.
okay, so our acceleration. So after subtracting and dividing by 0.31, we get 6.
For the velocity, I got 6.47
Okay.
meters per second.
So
I did that divided by 0.31 seconds, and I got 21.87 meters per second squared.
21.887. Okay, somewhere in that vicinity. Whatever it is you get on your calculator, we know that this is close. Some people are going to say, well, I got 21.17. I got 21.37. Okay, so what you got on that calculator, that's what we're putting here. And that's meters per second squared. So now we've got our acceleration. So we're getting one step closer. We solve for our acceleration. We still need to calculate that momentum, but we can't do that without the mass. So how do we find our mass now? Okay, with our force formula, we know that 2,000, our force, is going to equal what's on our right-hand side. The acceleration that we just calculated, which is approximately 21.87. Okay, 20.87. Okay. So then we have to have a variable. What are we looking for here? We're looking for our mass, so that we don't know. Okay. So how do we get m all by itself now?
Divide itself and do it the other side.
Okay, so we're going to divide this side by 20.87. Same thing over here. So our mass is approximately what?
Isn't it 21.87?
Oh.
95.8.
Okay. Let's hang on here. So 7.11 divided by 0.31, and because of rounding, I got 22.93. Okay. Oh, I know what I did wrong. I punched in 0.071. Okay. So 7.18 minus 0.71. So that gives us 6.47 on top. We divide that by 0.31. And that gives us 20.87.
I did 2,000
Oh, no, you were doing two different things, okay? So 20.87, okay? Then you divide 2,000 by 20.87. And 95.83, okay? So our mass was 95.83 kilograms. So, my, that must be one heavy glove. But we're going where the numbers lead us. How do we finish this problem now?
You have to find,
You have to do.
Okay, so our momentum formula tells us now that our mass, 95.83 times our final velocity, 7.18, and our momentum is what?
620.02.
Did anyone else get 620?
688.05.
688. That's what you got? That's what you got? 688. Okay. 688. Okay. Point whichever. Okay. So it's easy to make a mistake with this. All right. Is there any questions over this? Because as we move forward, okay, and you know this, if you're having problems with this, whose responsibility is it to ask questions? It's your own. Okay, yes.
Where did 7 oh, that's the final velocity.
And again, you may or may not see a problem like this. Maybe this is similar to what you find on the exam. There's worth a lot of points. Okay? So to really help yourself out, what is the best thing that you can do? Writing down your information. What else is the best thing you can do? Showing your work, labeling your answers. Okay? So front row. Are we on the bus here? Okay. Second row. Third row. Okay. So for those of you nodding your head yes, if we can solve this, we will hopefully be all right tomorrow then. Is that correct? Yes. That's what you would presume, right? Okay. We want to make those presumptions. So hopefully that leads to success. Okay, we're going to head over to the lab here shortly. Okay, hang on. I said shortly. I didn't say right now. We'll catch up to you next time.